Hello everyone. In this video I'm going to speak about covalent bond. Let's get started. Covalent bond is formed when electrons are shared. How this covalent bond is formed? It is an electrostatic attraction. Like the ionic bond, both of them are electrostatic attractions. But if you can remember, in the ionic bond, it is formed between positive and negative ions. Here we don't have ions. It is covalent bond formed when electrons are shared. So we don't have loss or gain of electrons. But we have shared electrons, and the nuclei of the atoms. As you might know, the shared pair of electrons are of course negative, and the nucleus of any atom has to be positive. For that reason, we can call the covalent bond an electrostatic attraction. We will draw some examples about the covalent bond. The first one we have here is fluorine, F2. Before we think about how the covalent bond is formed between fluorine atoms, we have to write the electronic configuration. Do I have to write in subshells or main energy level? It does not really matter. So we'll just write the basic electronic configuration, the main energy level. We already know that fluorine has 9 electrons from the periodic table. You can always check that. So it is 2, 7. Okay, so it has 7 electrons in the last shell. How many electrons are needed for this fluorine atom to make its last shell full? Of course, it needs only 1 electron. Since we have 2 fluorine atoms, so we will have, as you can see here, we have fluorine, another fluorine, and we have a single bond formed between the fluorine. We don't have to forget about the remaining electrons, which we call them lone pairs. So what is happening here? We have 7 electrons in the last shell. We have 1, 2, 3, 4, 5, 6, 7 electrons. And to make the last shell full, it would share this electron with another atom of fluorine, which has already 7. And now those 2 electrons are shared between those 2 atoms. We can also show that by making those circles. We can see that those 2 electrons are counted with this fluorine and with this fluorine. But I don't have to make those circles when you are drawing Lewis structure. Lewis structure, as we will discuss it later, is just showing the valence electrons. What kind of covalent bond is it? It is a single bond, single covalent bond. Let's do the same thing with oxygen. Oxygen has how many electrons? It has already 8 electrons, so it is 2, 6. So how many electrons are there in the last shell of oxygen? It has 6 electrons. We need to think, okay, how many electrons are needed to make the last shell full? Yes, 2 electrons. Because our reference or the last shell will be full when it has 8. So we have an oxygen atom, another oxygen atom. We don't have to forget about all the valence electrons. It has 6 valence electrons, but it would need to use 2 of them to make the covalent bond. So we have 1, 2, then we have how many electrons are left over? We have 1, 2, 3, 4. This line is representing 2 electrons or a pair of electrons. Same here, 1, 2, 3, 4, 5, 6. We cannot mix between dots and lines, so we'll make this line, as you can see here. And this line is representing the covalent bond. And here we have a double bond. Here we have a double bond that is formed between oxygen atoms. And now each oxygen has 8 electrons. How I can check that? You can make this circle and you check we have 1, 2, 3, 4, 5, 6, 7, 8 electrons, and same for this atom. Okay, I think now you get the idea. For nitrogen, it has 7 electrons, so it is 2, 5. It has 5 electrons in the last shell, so it would need 3 electrons to make the last shell full. So I have nitrogen, another nitrogen. Oh, it needs three electrons. So it would use 3 of the valence shell electrons, 3 of the last shell electrons. So which means that we have 2 electrons that will not be used in the bond, in this covalent bond. So we have here 1, 2, and 3. Okay, so as you can see here, we have here 1, 2, 3, 4, 5 electrons in each nitrogen atom last shell, 5 electrons, 5 valence electrons. But after making this triple bond, now you can count how many electrons in the last shell. 1, 2, 3, 4, 5, 6, 7, 8. So it's already satisfied. Same with this nitrogen. Do I have to draw those circles? You don't have to draw those circles, but you just can do that to count how many electrons are there after the formation of the covalent bond. Again, how many covalent bonds each atom should make, it depends on the last shell electrons. How many electrons does each atom has? If it has 7, so it would make single bond. If it has 6, so it could make double bond or 2 single bonds. If it has 5, so it means that it needs 3 more electrons to make the last shell full with 8. So it would make triple bond or 3 single bonds. There is a very important note here, which is about the pairs of electrons in the outer shell of atoms that are not involved in the covalent bonds. They are called lone pairs. So this is a lone pair, this is a lone pair. Same here, we have 2 lone pairs surrounding oxygen atom. We have, for fluorine, we have 3 lone pairs.